come back from our impromptu coffee break before the next coffee break. So our next speaker, our final keynote speaker this morning is Roger Grimes. We're thrilled to have Roger here. Roger is a industry veteran and expert in all things cybersecurity. He's authored many books, frequently quoted, and you see op-eds from Roger all the time. So Roger has joined us today to walk us through common mistakes that allow MFA to be hacked. So Roger, I'm happy to turn things over to you.
Thank you. Hello, hello. Thanks for showing up today. I'm here, I think, because I'm kind of known as a guy that hacks MFA, or one of the many thousands of people that hack MFA. Literally wrote the book on it, Hacking Multi-Factor Authentication, and in that book I talk about 50 different ways, over 50 ways that you can hack different MFA solutions. I have hacked dozens. I have security reviewed, I think, up to 162 now is my count. So I certainly have a lot of experience. I've deployed hundreds of MFA solutions throughout my career, and I've earned all these gray hairs because I'm on year 34. Been a pen tester for 20 years, and in that time, people would frequently say, hey, can you pen test these different MFA products, or can you do, sometimes it'd be like 10 products or 20 products of a particular type. Can you try to break into biometrics or one-time password products or whatever? Let me say, in every case, me and my team were able to break into every solution that we were ever given. And although sometimes it's, breaking into a particular solution, a lot of times it's breaking around it and bypassing it. So I've been giving talks for about the last 3 years on this topic, and they said, can you talk about that here? Can you talk about all the ways you can hack MFA here? Sure. How long do I have? 25 minutes. So I'm not going to be able to talk about all the ways I can hack an MFA, but I am going to cover a couple common things. But a lot of people say, can my MFA solution be hacked? There is no doubt. There is nothing in this world that is unhackable in this world. Everything can be hacked. MFA can be hacked. MFA can be bypassed. But some solutions like FIDO are more resilient than others, and so I do certainly have favorites, and I have ones that are, not as strong. But I do like MFA. I'm a big believer in MFA. I'm delighted that feels like we're all together in something that's getting ready to kind of take over the world, so it feels good. But one of the first types of MFA attacks I wanted to talk about was man-in-the-middle attacks, because this is probably successful against I'm just guessing, I don't really have the numbers, but 80–90% of MFA solutions. And just recently, the U.S. government, through the Biden executive order, said that they're trying to make people get away from phishable MFA. And if you looked at the list of MFA they considered phishable, by the way, I agree with that list, but it's probably about 80 or 90% of all MFA in the world. And I work for Noble4. We're a company that tries to fight social engineering and phishing, so it certainly is something that we think about all the time. But this is very true that in this case, you're not necessarily phishing the MFA solution. You're phishing the human, trying to bypass the human, trick them into doing something they wouldn't otherwise do. And it is very, very common. So with an MFA attack, the really common things that the bad guy or girl or person or they convinces the victim to visit a fake website through an email or social media thing or something like that. But the victim thinks that they're going to a site that they intend to go to, that they're going to log on using multi-factor authentication. And what the bad guy did is trick them into going to some man-in-the-middle proxy website that then will then connect to what the server they thought they were going to or service. And so everything sent from the victim to the eventual destination service and from the destination service back to the victim gets captured. And that can include a password and logon name. It can include, it can be MFA credentials, those 4- and 6-digit codes that we send in there. It can be the access control token. Most of the time when people sign on to a service, especially on the internet, the resulting access control token is a cookie, is a text file. They can capture and replay that and take over the account. This is very, very common. First time I wrote about this for the first time was in 1997. So it's been around this for quite a while. It still is one of the most common ways. Millions and millions of credentials have been stolen this way. And I'm going to give you Kevin Mitnick, who is our chief hacking officer, longtime hacker, been around, but he demos this in all sorts of different solutions. And we're not picking on any one vendor. This is just a particular way, a very common way that somebody can be phished out of their MFA credentials.
logged into my Gmail account, and if you take a look in the second email here, I'll go ahead and open it. It appears to be an email from LinkedIn. And ordinarily, when somebody wants to join your network on LinkedIn, LinkedIn will actually send an email to your email address notifying you of that. And if you're interested, you can go ahead and click interested, log into your LinkedIn account, and authorize that person to actually become a connection. So if we take a look here, we have an email from LinkedIn that says, Kevin, I've read about your adventures in Ghost in the Wires and so on, and this person wants to join my network. But this is actually a phishing attack. If we take a look here at where the email is originating from, it's not at linkedin.com, it's at this domain called llnked.com, which people might overlook. So let's go ahead and pretend that we're the victim here and go ahead and click on interested. And what that is going to do, it's going to redirect us to the LinkedIn website to go ahead and log in. But let's move this over to the right and let that load. And if you take a look over here, we have a blank white page, which is going to become very important in a moment. And this is the attacker terminal session. So let's go ahead and bring back the virtual machine that's now connected to LinkedIn to Authenticate, because we, again, clicked on interested in the email. So we'll go ahead and put in a username, Johnny Boy, at mitnicksecurity.com. And now we're going to go ahead and put in our secret password. And now we're going to go ahead and click sign in. And when we click sign in, it's not going to allow us to log in. What LinkedIn is going to do is request our two-factor authentication code that LinkedIn is going to actually send to my mobile phone. And in a moment, you should hear a sound that the text message was received on my mobile phone. So let's go ahead and click sign in. And here we go. It's telling us that two-step authentication is enabled. We just heard a message come into my mobile device. We're going to uncheck this box that says recognize this device in the future. And I'm going to open my mobile device to take a look and see what the text message is, or what the code is rather. So the code here is 421476. We're going to go ahead and click verify. And when we do so, it's going to log us into my LinkedIn account. So now we're logged into the LinkedIn account, but let's take a look at the attacker session over here on the left. So we're going to scoot this over to the right. And over here, what we have is what we're able to intercept. So we're able to intercept the email address, which is johnnyboy@mitnicksecurity.com. We're also able to intercept the password to the account, which is KnowBeforeRocks. And over here, this is not the actual 6-digit code that was intercepted, because you can't really use the 6-digit code again, the second factor. But what we're able to do is intercept the session cookie. And if you're able to steal the session cookie, or if rather the attacker is able to do so, they don't even need your username or password or second factor code. They could simply load the session key into a browser and they actually become you. So let me show you how this works. We're going to highlight the cookie. We're going to copy it to the clipboard, and then we're simply going to open up Chrome in incognito mode. And incognito mode just means with privacy. So now we're going to go to the real LinkedIn website. When we go here, obviously we're not authenticated. Now it's, wants us to log in with our credentials, but we don't have to do so. We're going to go ahead and go into developer tools. We're going to go into the console, and what we're going to paste into the console is the session cookie that we stole from the victim, which was myself, by the way. I'm going to enter it. I'm going to go ahead and close the session. Now, all I simply have to do to be logged into the victim's account with their session cookie is simply hit refresh now. So I hit refresh, and here we are. We've logged in, or rather hacked, my own account.
So everybody in this room is probably going, oh, boring, boring. You all knew about it. You knew about this type of attack. It's one of the most common types of attacks against MFA. But when I show this demo around the world, without a doubt, people are just shocked. Like the average end user, the average sysadmin. I have people all the time going, have you told LinkedIn about it? Have you made a CVE? Have you filed a CVE about this big attack? And I'm like, it's not an attack. It is as designed. It's the way that it kind of works. And this attack like this or similar attack works against 80–90% of MFA today. But end users think the exact opposite. They think that they're far less likely to be attacked because they're using MFA. And the fact is, I can send an email. It's a little bit more crafted and requires more setup for the attacker on the front end than a regular phishing email. But to the end user, it's just a phishing email. And if they get tricked into clicking on the wrong link and they don't notice that misdirection, it's game over. And that's a big, big deal that if the average user, and I'm making up a stat here, but probably 99% of end users, when they're given this MFA, suddenly feel like they're far less likely to be hacked. And that's true to some extent from some types of attacks, but can they still be phished? Yep. And so you need to educate end users. You got to make sure that you click on the right links, right? Depending on what type of MFA they have. In this case, Kevin used a hacking tool called Evil Jinx, but there's dozens and dozens of tools that do the same types of things across wireless networks and wired networks and all kinds of different tools. And if you go look on the internet, Kevin has all kinds of demos doing the same thing against all kinds of different sites, because he had had people go, well, it worked against LinkedIn, it wouldn't work against Gmail. So he did one against Gmail. Well, it worked against Gmail, it won't work against PayPal. So he did PayPal. It won't work against a bank, so he did a bank. I mean, it's not that the sites are set up wrong. It's just that the MFA solution can be, you can hack the human, right, around it. So this is certainly a big deal. Again, the U.S. government has recently said, we're trying, if we're trying to use MFA, particularly to stop people from being phished so often, we need to make sure that we design MFA products that can't be phished so readily. Let me say I'm excited because FIDO and FIDO 2.0 is not susceptible to these particular types of attacks. So that's a good thing to hear. But here's another type of thing, this SMS Rogue Recovery. The attacker would have to know that you have some type of account that can be reset using SMS and know what your, email address is. So this would be, like a Gmail or O365 or something like that. But they could send somebody an SMS text claiming to be from, Google Security or Microsoft Security or whatever it might be. We've detected a rogue sign-in to your Good Guy account. In order to determine legitimate login, we're going to send you a verification code to your previously registered phone number from another Google support number. Please retype the sent verification code in response to this message, or your account will be permanently locked. You have to give them the threat of God. They're going to lose access to all their pictures or whatever. And then the hacker would then go to just Google, go to Gmail, put in the victim's email address, say they forgot their password, and they have because they don't know it. Gmail's nice and says, do you want to use the last password you have? You say, no, try another way. And then there's 4 or 5 ways that you can try to recover that account, one of which is SMS-based. So it says, send this to here, get sent this verification code. And let me say, they might have updated this. If they haven't, I've certainly seen other ones where they'll say, do you want me to send a verification code to this number? And then they have to type in the whole number. That's a really good anti-phishing technique, right? Where they have to know the whole number before they can send it. But when I took this picture, that wasn't the case. But then they get sent the code, they type it back into, return to the hacker, and it's kind of game over. Right, they take over the account. What's weird, I even have a lot of people email me and say, hey, my account got taken over, my Instagram or LinkedIn account or whatever, and the hacker then turned on MFA, and I'm now unable to get my account back, no matter how hard they've tried. I always tell people, I'm sorry to hear that. And they always go, Roger, can you hack it? Can you hack it? I'm like, I'm sorry. Microsoft and Google's and Instagram's terms of service don't allow me to hack their account just because it's been taken away from you. But don't let the hackers be the only people that are enabling MFA on your account. Beat them to the punch. But really, it can be almost anything, right? If you're sending these PIN codes to people, you can initiate them at any time. Like you go in and you find, oh, okay, I've got Roger's account. Does Roger belong to this thing? And, oh, I can recover his account with a PIN. If we can do an SMS recovery, well, then I can come up with all kinds of scams in my head. Like, Roger, have you been enrolled in the National Weather System's tornado warning system? Please reply yes or no. So you're getting them to buy into this thing that, yes, I want to be notified of tornadoes or hurricanes. Thank you. Please reply with the confirmation code just sent to confirm your phone number. The victim does it, and it's game over, except for that code is not from that service, that non-existent service. It's from whatever they're trying to break into at that particular time. They get sent a code. They think that, oh, look, the code just popped up like they told me it would. I now respond to it here, and now the hacker takes it over. And really, you can make this up all day long, right? You can make up something to socially engineer and motivate somebody. Google just put out a report. I think it was just yesterday. They were talking about Russian ATP. I think it was 27 or 37, something like that. But they said that's their primary method of getting into people's accounts is they'll send security researchers phishing emails introducing themselves and then inviting them to go to a security conference. And they send them to a fake security conference website and then say, oh, as you're signing in as your registration, you have to input this PIN code. And that PIN code just happens to be the PIN code to reset their Gmail, Microsoft, or whatever account. And if you looked at it, it was a fairly sophisticated attack, but they said that was that group's primary way of stealing accounts from people for like the last 5 years. So I'm using simple examples here, but it's a, not an uncommon thing. And the problem in this particular case is that we know that SMS and voice-based phishing is that it really is unauthenticated. You can claim to be anybody from anywhere and send a message to somebody. You can even fake the phone number, and you can fake what's called the short message code and claim to be anyone. And there are ways to stop this, and that's part of, as you're implementing an MFA solution, try to think of ways that would stop something simple like this from happening. The Penbased MFA, I just put this in here because it's kind of a funny thing, but there's a lot of Penbased MFA where you put in a pen code or something like that. Well, when I pen test, when I'm a pen tester and I find someone's pen code, if I'm able to discover it, almost always they use that same pen code everywhere. Like they're not only using it with their MFA or with their, to unlock something. If it's on their, if it's the pen code they use to unlock their garage door, it's the same pen code they use to go to their ATM. And I notice these patterns. Like there is the elevator code of a building that I frequently enter, and I don't think I have to guess about which numbers are being used and whether or not I have to hit a pound sign at the end of it, right? Pretty easy to see. The other picture on the right is from my brother's. I got a twin brother, he loves his Tesla car, and he was worried about people being able to drive off with this Tesla because it turned out when his engine, if he'd accidentally left his keys in his Tesla, the mirrors would stay out. So he was like, oh, anybody that knows Teslas will know your keys are in that car and they may steal it. He said, so Tesla developed this PIN code, PIN to drive, that you had to put on in there. And I showed up at his house, he's like, oh, you guys see this new PIN to drive thing? I went, oh, is your code 2569? And he sat there shocked. He was like, how did you know? I was like, I can see your fingerprints on your screen, about where it would be. But I've also noticed with Penbased MFA, it's almost a rarity that vendors do rate limiting or account lockout. I think in our password policy stuff, it's pretty common that you'll get account lockout. I put in the wrong password 5 or 6 times or something like that, and it locks it out. For some reason, like version 1 of all PIN codes implemented by vendors just don't have that, or they can be kind of hacked around. But I find literally, there's dozens and dozens of these very popular services that implemented a PIN code that didn't have rate limiting or account lockout enabled on them. Like there was one on Instagram where the guy found out he could guess. It limited you to 250 guesses per IP address, but there was only 1,000 guesses he needed to make. And so he just got 4 different, machines up on the internet and was able to guess through them all. And it, cPanel, same thing. You can bypass in a minute with brute force attacks. Or here's one that was announced against Slack. My company uses Slack. But there are many, many popular services when they implement PIN-based MFA that forget to put rate limiting on it. And I've been doing security for a long time, and so you think, well, nobody would possibly implement something like that where you had to input a secret and not put account lockout on it, but it turns out lots and lots of very popular services have done so. Or transaction-based MFA, where someone's going to buy something maybe on the web and they get some type of approval message there. Maybe you might call it push-based authentication. Hey, do you want to approve this transaction? Well, yeah, I'm trying to buy this TV at the site. But maybe if you found out that that site, because you've been man-in-the-middled, wasn't the site that you thought it was, it'd be better if you got more information that would give you more context. So when you're doing transaction-based MFA, give as much information as you can so the end user can make the appropriate decision. Or here are some other push-based notifications, which I love. I love push-based notifications. Let me say, I consider push-based notification one of the MFA types like FIDO that I really promoted and thought were better than another. And here's some solutions here where you approve it. The first one, I was like, well, it doesn't have a location. The second one does have a location that would show you that I live in Tampa, Florida. Although I noticed when I was using VPN, my company started using this new VPN service that my location would show me that I was in DC, then Arizona, then whatever, and it was teaching me to ignore the location. But even crazier from this is that I've been talking to a lot of pen testers about push-based 1 MFA, and they just absolutely love it. And the first time I heard this, I was talking to a security person that was at, they were helping respond to a ransomware attack where the company had been ransomed out of tens of millions of dollars. And what they found, and they used push-based authentication, and it turned out that what had happened is that their CISO had 50 times approved a login connection that they were not related to. The location said Russia on it, and they approved it over 50 times. And they said to the person, well, why did you approve it so many times when it wasn't you logging in? And they said in desperation, I was just told, whenever I got this prompt, I was supposed to push approve. And I'm thinking, well, when the person was, and I understand that I've implemented MFA, you just are trying to get it out, and people are mad at you because it's harder than different than what they used to do, so you're just trying to get it working. And I said to myself, did the person never mention to them that, hey, if it's not you logging in, hit deny and call IT security? Or did they say that and the user didn't hear it? Because we may be aware but not care, and we forget about it. But it's a training issue. And I went, wow, I was thinking, how crazy is that? And so I started calling all my friends that do red teaming and pen testing, and they say they absolutely love 1FA, push-based 1FA, because they always have people log them in. One person told me that 3 out of 5 people will approve the prompt when they send it at any time, day or night, when the person's not logging in. One guy told me, he said, it's like walking up to a New York City building, hitting the keypad for all the buzzers, and just waiting for the people to buzz you in. He said he's never not broken in. I asked all the teams I was interviewing, would you recommend push-based 1FA? And they all said no. And let me say, if you have 2FA at least, maybe it's a password or something else that's going with it, that helps you. But let me say, I still like push-based 1 MFA. It is clearly a problem that we're not educating sysadmins and people that deploy these of how to educate themselves and their end users. We're not educating our end users. We think it's common sense that you should say deny when it's not you logging in, but it's not common sense. Even another story, I was talking to a guy that had to deploy it across a bunch of oil workers. He had thousands of oil workers that he wanted to implement his MFA across, and he said, forget the problem that, and their solution involved a phone, that a lot of those people did not have smartphones, but they had a hard time educating them about how to use this push-based authentication. So many of them got frustrated that they actually they changed their phone number where it was pushed to be their boss or a coworker. So their coworkers and their bosses were approving the login prompts all the time for them, even though they were not the ones logging in. And I read another story where the same thing happened with this other guy, and they had caught the supervisor, all the people working on the supervisor, he was approving all of them at all times and days and nights. And when he got caught, he said, listen, I'm just trying to have my guys do their work. So they said, don't do that. That's bad. Don't do it. You're undermining the whole system. They came back a month or two later. He was still doing the same thing again. So this just kind of comes to the end that and you can do the same thing with one-time passwords, right? Anytime you've got those 4- and 6-digit codes, a lot of times, if the device and the MFA solution is not tied to the device and the device to the service or the website where you're authenticating, there can be that man-in-the-middle attack that captures that code, right? There's lots of people at Coinbase a week or two ago that learned that lesson, right? It's a really common way that people get tricked into going to the wrong website. They lose that code is intercepted, and then the bad guy, uses it to log in and take control of their account. But really, I'm a big believer in MFA. I'm excited to be part of this world at the time when it's finally going to take over. But there is coming from a company that really cares about phishing and social engineering. What I'm seeing is kind of seeing a lot like we're pushing MFA, and then it seems like a whole lot of MFA can be phished. And the U.S. government knows it, right? Because they're literally trying to outlaw it in the executive Biden order. They're trying to get rid of, and when they say we're trying to eliminate fish-based MFA, and they include one-time tokens, push-based authentication, PIN codes, and SMS, That's like 80, 90% of what's out there right now. And there are ways to prevent that. There are clues and tricks, like I was talking about with the phone number. When you're told to put in a phone number, make the person that's trying to send that phone number put in the whole phone number. Give people more transactional clues about what they're doing, better education. So just my end thing to say here is the whole reason we're going to MFA is to try to prevent social engineering phishing attacks. Let's not repeat the same problems that we had before MFA with MFA. But anyways, thanks a lot, everyone. Enjoy the rest of your conference.